Welcome back, children. Now, yesterday, as I told you regarding the properties of metals, some features of exceptional metals I must tell you. For example, as I said that sodium and potassium, they are the softest metals. They are so soft they can be easily cut with a knife. Similarly, I said that metals are generally hard. They are solid at room temperature. Again, there is an exception. Two metals are there which are found in the liquid state at room temperature. These are again exceptions. For example, mercury. I think you know what is mercury, which is used to make thermometer, barometer. So, mercury is a metal which is found in the liquid state at room temperature. Similarly, gallium is another metal which is found in the liquid state at room temperature. So these are some exceptions which you should remember. Now, today we'll do the physical properties of nonmetals. Let us see. Physical properties of nonmetals. First point. They are generally found in the liquid or gaseous state, at room temperature. Definitely exceptions are there that I'll let you know later. They are soft and brittle if found in the solid state. Right? They have low density. They have low melting point and boiling point. They are non-malleable and non-ductile. They are poor conductors of heat and electricity. They are not sonorous. Now, for example, nonmetals, they are generally found in the liquid or gaseous state. Now, gaseous state, you know, oxygen, hydrogen, nitrogen, all these gases, chlorine, they are all found in the nature in the gaseous state. Bromine is a nonmetal which is found in the liquid state. Now, next point of evidence, they are soft and brittle if found in the solid state. For example, sulfur. Sulfur is a nonmetal, but it is found in the solid state. It is soft. You can easily crumble them in your fingers. Now, graphite is also a nonmetal, which is an allotropic form of carbon. It is also a nonmetal. So it is also found in it is very soft. On the other hand, Diamond, which is also an allotrope of carbon, it is the hardest substance in nature. So these are exceptional cases which you must remember. Remember, diamond is the hardest substance found in nature, which is made of carbon. Now carbon is a non-metal. So here it is an example. Similarly, metals, unlike metals, non-metals have low density. They have low melting point and boiling point. Now again, graphite has a very high melting point. Remember, clear? Graphite has a very high melting point. So this is again an exception. They are non-malleable and non-ductile. Means you can understand, neither they can be beaten into sheets, nor they can be drawn into wires. They are poor conductors of heat electricity, generally. Again an exception is there. Graphite is an exception. Graphite is a good conductor of electricity. Remember. So, some exceptions also exist in non-metals which you must keep in your mind and should not forget. And definitely, non-metals are not sonorous. So, if you remember the properties of metals, then for non-metals you can easily write the properties just by reversing it. Opposite. If you write the opposite properties, it will become that of non-metals. So, if you remember the properties of metals, then for remembering the properties of non-metals, just write the opposite properties. So, it's very easy to remember. 6-7 points, I think more than enough as to differentiate between the physical properties of metals and non-metals. So elements, I told you, they are broadly divided in two parts, metals and non-metals. Physical properties of metals we have already done. Now we have done physical properties of non-metals. Now there is a third type of element which lies in between metals and non-metals, and they are called as metalloids. Now what are metalloids? It's very interesting. Some elements are there which have few properties common to metals and some other properties common to non-metals. Clear? Means some properties are similar to that of metals, while some other properties are similar to that of non-metals. So these elements which are having some properties of metals and some other properties of non-metals, they are called as metalloids. Clear? For example, silicon, germanium, arsenic, antimony, examples are there, etc. So, I have given you 4 examples: silicon, germanium, arsenic, antimony. These are metalloids. Why so? Because they bear properties which are similar to both metals and non-metals. So metalloids have properties which are intermediate to metals and non-metals. Clear? So for today, this is all. We will go more about metals and non-metals regarding chemical properties in our next class. So thank you. Please like the video, share the video, and subscribe to our YouTube channel. Thank you till the next class.